Welcome. In this video, we'll explore extreme programming, often called XP. We'll look at the values, principles, and practices of this highly disciplined Agile methodology. Extreme programming is an Agile methodology that places a strong emphasis on engineering excellence. It was created by Kent Beck in the late 1990s. It emphasizes technical practices and team dynamics. Extreme programming is designed for rapidly changing requirements. Some of the key characteristics of extreme programming are short development cycles, an incremental planning approach, reliance on customer feedback, a focus on technical excellence, and promotion of a collaborative team environment. Extreme programming is built on 5 core values: communication, feedback, simplicity, courage, and respect. Communication involves direct, face-to-face interaction between all team members and stakeholders to ensure everyone has a shared understanding. Feedback means continuously gathering input from tests, customers, and team members to adapt and improve the system. Simplicity focuses on doing what's needed and no more, aiming for the simplest solution that could possibly work. Courage involves taking bold actions like throwing away code, being transparent about progress, and adapting to change. Respect ensures team members value each other's contributions, expertise, and well-being, fostering collaboration. Now let's dive into the key principles of extreme programming. Rapid feedback is crucial. You should aim to obtain feedback through short cycles, continuous testing, and frequent customer involvement. Think in terms of minutes or hours, not months, which enables quick course correction and reduces waste. The next principle is to assume simplicity. Treat every problem as if it can be solved with a simple solution. Design for today, not tomorrow, and avoid speculative complexity. Refactor when needed. Incremental change involves making small changes that move the system toward the desired goal. Solve problems in small steps with continuous integration and evolutionary design. Finally, embracing change means welcoming changing requirements, even late in development, as change is inevitable and valuable. Adapt your processes to accommodate change and build systems that are change-friendly. Extreme programming relies on a set of engineering practices. Let's start with the development practices. First, pair programming means that 2 programmers work together at one workstation. One programmer, the driver, writes code while the other, the navigator, reviews. This allows for continuous code review and promotes knowledge sharing. Second, test-driven development suggests that we should write tests before writing the code. This follows a red-green refactor cycle, ensures testable code, and provides immediate feedback. Third, continuous integration emphasizes integrating and testing code changes frequently. Integrate at least daily with automated build and test processes to catch integration issues early. Fourth, refactoring involves restructuring code without changing its behavior to improve design incrementally, reduce technical debt, and make code more maintainable. Now let's examine the planning and customer collaboration practices in extreme programming. First, user stories are short descriptions of functionality from the user's perspective. These stories are written by customers, focus on business value, and serve as the basis for planning and acceptance tests. Second, small releases involve releasing minimal useful feature sets frequently, typically every 1 to 3 weeks, to deliver value incrementally and get feedback early and often. Third, the planning game is a collaborative planning process between the business side and the development team. The business sets priorities, the development team estimates effort, and together they negotiate the scope for iterations. Fourth, on-site customer, where a real customer representative works with the team and is available for questions, provides immediate feedback, and participates in acceptance testing. Now let's explore the design and team practices. Simple design means creating the simplest design that works for current requirements. It passes all tests, has no duplication, expresses intent clearly, and minimizes classes and methods. Collective code ownership allows anyone to change any code anywhere in the system. No individual owns code, encouraging knowledge sharing and reducing bottlenecks. Coding standards involve consistent coding rules that all team members follow. These standards are agreed upon by the team, making the code look like it was written by one person, and facilitate communication through code. Lastly, sustainable pace emphasizes working at a pace that can be sustained indefinitely, avoiding burnout. Teams typically aim for a 40-hour work week, with occasional overtime acceptable, to maintain long-term productivity. Let's compare extreme programming to other Agile methodologies like Scrum and Kanban. Extreme programming features highly disciplined engineering practices, a test-first approach, pair programming, and continuous integration. It has a flat team structure, an on-site customer, and collective code ownership. Its focus is technical excellence and high-quality code. Scrum uses fixed-length sprints, typically from 1 to 4 weeks, daily stand-up meetings, and sprint planning and review. It is less prescriptive about engineering practices. Scrum has defined roles such as the Scrum Master and Product Owner, self-organizing teams, and cross-functional team members. Scrum's focus is project management and team coordination. Kanban emphasizes visualizing workflow, limiting work in progress, and has no fixed iterations with continuous delivery. It has fewer defined roles with a focus on workflow efficiency, and specialists may be common. Kanban's focus is flow optimization and reducing bottlenecks. Implementing extreme programming can come with its own set of challenges. First, cultural resistance, because teams and organizations may resist extreme programming's disciplined practices. Possible solutions include starting with pilot projects, gradually adopting practices, and focusing on demonstrating value. Second, distributed teams may have issues. Extreme programming was designed for collocate teams, making practices like pair programming challenging. Some potential solutions are virtual pair programming tools, regular video conferences, and adapting practices for remote work. Third, scaling issues may arise, as extreme programming was originally designed for small teams of 10 to 12 people. Possible solutions here are using multiple extreme programming teams with coordination, a hybrid approach with other methods, and maintaining core practices at the team level. Fourth, customer availability, as having an on-site customer is often impractical in many organizations. Potential solutions include a dedicated product owner role, regular customer workshops, and scheduled availability windows. For successful extreme programming implementation, several factors are key. Team commitment means the entire team must be committed to extreme programming values and practices, sharing an understanding of extreme programming, being willing to change habits, and having a continuous improvement mindset. Technical excellence involves investing in technical practices and continuous learning with an automated testing infrastructure, a continuous integration pipeline, and regular refactoring discipline. Management support means leadership must understand and support extreme programming principles, provide necessary resources, remove organizational barriers, and allow teams to self-organize. Extreme programming offers a disciplined approach to software development that emphasizes quality, simplicity, and customer value. When implemented with commitment and understanding, extreme programming can lead to higher productivity, better quality software, and more satisfied customers and developers. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.